Hello everyone, welcome back to Coding Intuition. Today we are going to solve linked list cycle 2 problem on LeetCode. So let us quickly understand the problem first. In this question, we are given a linked list. We will basically be given the head of the linked list and we need to find out the point from where the cycle is starting inside the linked list. So as we can see in the first example, here the list, from here the cycle is starting. So we need to detect this position and return that in a solution. Basically, we will be given just the head and we need to return the position from where the cycle is starting. So I hope that makes the question very clear. So let us quickly jump to whiteboard to understand the solution and intuition behind it. First of all, at first understand the algorithm, then I will explain you intuition behind this algorithm. So in this algorithm, we will be having two pointers, slow and fast, and we will move one pointer to one node at a time and fast pointer to two nodes at a time. Let me show you how it will work. So as we move the slow pointer to 2, we will move fast pointer to 3. And we will do this until the fast and slow pointers meet inside this cycle. Okay. So let me do that. We will move slow pointer to 3, then fast will move to 5, we'll move it to 4, then fast will move to 7, we will move it to 5, then fast will come to 4, we will move it to 6, then fast will come to 6. So at this point they are meeting at a similar node, and this is 100% sure that they will meet at certain point inside this cycle, inside the cycle. And what is the intuition behind this, I will explain that shortly, but for now let us just complete the algorithm. So as soon as they meet at a point, then we know another thing. We know that this distance from 6, 7 and 3 and from 1, 2 and 3 will always be equal. I will explain the intuition behind this, but for now let us just complete the algorithm. So what we will be doing is we will just run head and slow together until they meet again. So we'll move ahead and move slow ahead, and we will go to 3, and we will go to slow will move to 3, and hence we find out the position where they both meet. So basically this is the algorithm, and now let me just explain the intuition behind the two things, why they will definitely meet at a certain point and why these two distances are equal. Let us try to understand how can we be so certain that these two pointers will be meeting at a point inside, if we have a cyclic linked list. So for that, let us consider the slow pointer is not moving at all, and this fast pointer is just moving one node at a time. That means the slow pointer is just staying here and fast pointer is just moving one node at a time. In that case, it will definitely meet the slow pointer, because the slow pointer is at a fixed position and fast is just moving one at a time. Okay, in that case we know that definitely it will definitely meet the slow pointer because slow is still. So now let us do one thing. Let us just increase the speed of both of them by 1. Okay, so now slow pointer will move by 1 and fast pointer will move by 2. So now that explains us that now, whenever if the slow pointer is moving by 2, it is destined to meet at a certain point because it will only 1 point ahead of the fast. As it is 1 point ahead of the fast, it will definitely meet here. So that is the intuition behind why they will meet at a certain point in the cycle. If this intuition is not clear to you, I have another intuition for you. Let us consider the two cases. We will only have two type of cycles. Either cycle will be odd or the cycle will be even. If the cycle is, let us say, even, in that case the fast will be moving only to the two nodes. In this case the fast will skip this node and go here, skip this node and go here. It will be moving this, and in that case it will definitely meet the slow, because as the slow is going 1 pointer at a time, it will definitely come to this or this, and they will eventually meet if the length is odd. And if the length is even, no, if the length is odd now, then in that case the fast will be going to each and every node. Yes, it will go to each and every node. Fast will come to skip this node and come here, skip above node, come here, now skip below node, come here. So it has covered all of the nodes, so it will definitely meet slow at a some point, because in this the slow is going to everywhere and fast is just repeating some nodes if the length is even. And if the length is odd, fast will definitely go to each and every node. That's why they will definitely meet at some point. Okay, so that is the intuition behind the meeting of fast and slow. Now let us try to understand why we have this distance, which is from 6 7 3 and 1 2 3 are equal to each other. So for that, let us consider that from our head to other point where our linked list, where our circular linked list is starting, the distance is x, and from the point where the fast and slow have met each other is y. So now the distance traveled by the slow pointer would be this x plus y, right? So the distance traveled by the slow pointer would be x plus y in this case. And the distance traveled by the fast pointer would be similar, x plus y plus adding the certain number of rounds it must have taken to complete the cycle. As we have seen that the fast is not meeting, it may meet it in the first cycle in some cases, but in most of the cases it will have to run through the cycle length of the cycle. So let us consider the length of cycle is c, and n is the number of cycles taken by y. So the distance traveled by the y would be x plus y into n c. And now we know this, that the twice the length of we are moving fast pointer twice fast as the slow. So whatever is the distance traveled by the slow, fast will be equal to the twice of that. Okay, so now we have this x plus y, which is the distance traveled by the slow, x plus y plus nc, which is distance traveled by the fast. And now we have this equation. As we move x plus y to left side, we will have this x plus y is equal to the length of cycle into some number of things. Now if we move y to that side, we will have x, which is this distance, equal to length of cycle minus this y, which becomes this length. So basically here we have proved that the length of our, if we subtract y from length of the cycle, this will be remaining in our hand, and this is equal to y. This is equal to x. Hence, this length is equal to this length. So that is the intuition behind that whenever these two meets, the length will be, the length here and length here will be equal. So I hope that makes intuition very clear. So let us just quickly jump to the code and here is the code for this question. So first of all, we will check if head is null or head next is null. We will simply return null, because there is no use of checking head, because if there is a single node, there will be no cycle at all. And first of all, we will assign our slow to head, our fast to head, and we will run a loop until we find slow is equal to fast, and we will break that. And this condition is for what? This is if this condition will come true if and only if there is no cycle and inside our linked list, and if the linked list ends, if it goes to the end, the fast, either fast will become null or the fast next will become null. So in that case, if the linked list has no cycle, this condition will become true and will break out and return null here. And by checking the same condition, we will return null here. And if we just break out by going slow and fast, what we will be doing is, until head and slow are equal, we will just move them one pointer ahead until they meet each other, and we'll return the head, and we will find out the position where the linked list is, where cycle is starting. So I hope that makes the code very clear. I hope it had helped you. Thank you so much for watching.